So clearly you guys like custom fabrication content on this channel. Thank you guys very much for all of the kind comments and everything else that you've dropped in on the last few videos. So we're going to go full steam. We're going to go head on into another one. Very, very simple control arm, but we have a very, very complicated layout to get the desired results we want out of this, this particular control arm. The stock design is extremely simple. How we get to the design and modifications and things that we're going to build from scratch on this one, very complicated. Now you guys asked for a lot of that math, the layout, how to achieve all this stuff, and while I think it's relatively dry, you may too. So once we get about, I don't know, halfway through this video, if you're not into it, you're not digging it, well, maybe you'll just want to skip to part 2, because that's where all that fabrication, all the rest of that good stuff is going in there. So if you want to know how it's all done, here's your video. There is a very common reoccurring tool in just about all of suspension fabrication. That tool is known as a jig. Now look carefully on the left of the screen. That's the control arm I just recently built as part of the 4-link series videos, and this is the jig that I used to build it with. And it's also the same one I used in part 1 of the 4-link videos to build the lower links, but right now it's going to be repurposed to hold this lower control arm. Now this control arm came off of a Mitsubishi Mirage, better known as a Lancer to the rest of the world. But it's I've always wanted to actually build one. I've never had a chance to. And despite looking so very simple, it's actually really complex with having adjustments and other things that I want to do that. Not to mention we got to go like square to round or round to square, and we don't have a lot of space to work with, in all honesty. So it's gonna be fun. I got a really great design in mind, and we'll make it happen. So these are the tabs that we got to cut out, and if you notice very carefully the hairstyle under the hood there, it's not mine. Mrs. TFS is actually over practicing the day that I started making this jig, so I had her weld it up. She's pretty good. We're going to drill all 4 of them at once after we tack them all together, and basically it's just going to knock my time, down a lot, because all 4 tabs have to be identical. Really easy. So we just cut them all off at once, and as soon as we pull them out of the saw, we have 4 identical tabs, which is exactly what we need in order to get all of this mounted up, and now we can move right on to machining the sleeve that goes in the middle. Now that sleeve measures out, according to this very crappy camera footage that you can't even see anyway, it measures out to somewhere around 1.9 inches. So it's I'm just going to cut it down to 1.9, and to do that I'm going to use some just junky little steel bar stock that I found in my scrap pile. Nothing big, no need to get anything like super fancy or anything like that. All we really need to do is pop a hole in it, which is the size of the bolt. Now what's really unique and kind of interesting about this build in general, or at least this control arm, is it uses metric hardware and metric sizes, but you'll see in a little bit that I actually have to do some conversion, if you will, to make some of it work out correctly. So this is a 12 millimeter bolt, or a 12 millimeter hole that I'm putting in here with a 12 millimeter drill. So not converting over or anything like that, but we'll give it a spin, get it all nice and shiny, get it cut down to length, and just go a little bit, I don't know, we'll just call this practice. I'm just going to clean it all off and put a little chamfer around the edges and everything like that, making sure that it's cut to the length properly. But a little chamfer around the edges, make it a little nice and clean. I need time to practice and work on my machining skills, so that's pretty much what I'm doing here with both of these pieces, or at least with this piece in general. So nothing really big, but I'm kind of proud of this one. 1.9 and a 5. Pretty close. So just some quick welding will get this job done, get all these tabs on here, and of course, nothing special. I mean, like I said many times over, you don't need to overcomplicate jigs. They don't have to be, super hardcore, super special, super pretty, nothing like that. Literally just placeholders. That's all it's going to do, is hold the place of everything. And I never feel like I can say this enough times. So quite literally, we just have some 1/8 inch tabs sitting, wherever they need to be in order to float this. And when it comes to doing the sleeve, I'm just going to throw it on, I think it's like a 3-inch tab. And I'll show you why I have a very long tab, longer than it actually needs to be. The other tabs are like 2 inches long. But here's the reason. I can't access it while it's in the jig. So the longer tab will kick it forward to a place where I can access it and tack weld it. And since I have a good solid tack and it cooled for a minute, we're going to carefully remove the control arm out of there and then reinforce this with a smaller piece just underneath it. It's going to make sure that it doesn't actually move on us, or if it gets bumped or anything like that, we want to make sure that it actually stays in place. So quick little weld, jig is done. Now this is a Heim joint, sometimes known as a rod end or a tie rod end or a spherical joint, or there's a dozen names. Just if you search Heim joint, H-E-I-M, you'll find them. They're everywhere. I picked this up in my local hardware store along with the bung and the jam nut. You'll need these if you're going to fabricate with tubes. Now, the unique thing about this is the Heim joint is a standard Heim joint. It's a 5/8 sized Heim joint. Everything else on this is metric. So all of my bolt holes and everything else like that and all the hardware is metric. I don't want to change it out on the chassis because I think that's a little bit cheesy. So we're going to have to machine some spacers and some adapters, which they're going to be a combination spacer and adapter, which is typically known as a bushing. Now, here's where it gets interesting. The total width of the pocket that we have to go into after measuring the sleeve on the control arm is 1.95 inches. The Heim joint itself is 3/4 of an inch, or 0.75. So we have to space that out. But to make sure that it's centered, we need to subtract the width of the Heim joint from our total width of the pocket. We get 1.20 inches. That's the total difference between the two of them. But we have to make it equal on each side, and since we have to have a portion go into the Heim joint or a shaft go into the Heim joint, we also have to have a shoulder that comes off of it to provide the spacing and make sure the Heim joint doesn't shift left or right. Therefore, if we take 1.20, divide that by 2, that's each side or each shoulder length that we have to do. And if we take the Heim joint at 0.75 and divide that by 2, we get 0.375. That's the shaft length. So now we know what size bushing we need to turn out here in the lathe, which is really simple. Now, I mentioned before that, very basic machining is pretty much what I can do. I can turn some parts down, I can make some things take shape and all the rest of that. I'm learning, I'm working on it, but of course, in my industry, we always just, passed off the important stuff on to machinists, and I still do that, except every now and again I'll take on a job of my own. But this is a very simple part to turn down. We need a shaft, we need a shoulder, it needs an OD, it needs an ID. It's really not rocket science. I like to chase it all down so I get a good visual reference and I can just fly through the thing. That's why I ended up getting it close to, at least a rough diameter size. I always did this because it was kind of one of those things like somehow I would screw it all up in the beginning and not measure correctly, but for some reason if I chase it out the smallest amount, then I'm not scrapping as much metal if I screw it up somewhere. So as soon as I get the shaft cut out, I'm going to trim it down. The OD is going to be trimmed down, and I just basically settled on 7/8 of an inch, which will do just fine for everything I need. Now I'm just going to get it all cut down, and everything was great until my tool broke. I'm not really sure what happened, but just before, like when I hit it with the oil, it just literally just kind of shattered and then drove itself underneath the freaking the part and got all jammed up and junk, and I had to go reset the lathe. But my solution was just to go to the trusty bandsaw before resetting everything and making it all line back up again so I can finish this part off, because, I don't want to redo that. Now, I did take a minute to readjust and reposition and get everything back and correct in the lathe again, like getting everything all squared up and all the rest of that good stuff. I didn't put all that on this video or even catch it on camera because it doesn't need it. Anyway, back in the lathe, we're good to go. Just need to pop a hole in this thing, and that's pretty much it. Now, this is the second one that I did. The first one, I tried to start it with a smaller hole, but I was getting a lot of chatter. So the second one here, I just went full bore on the thing at 12 millimeters. So chamfer them out, get it all nice and cleaned up, double check, verified, everything's good to go, and then we throw it back onto the jig with the Heim joint. Here is one sleeve, pretty tight fit. I'm satisfied with that. Sleeve number 2, got it in on the first go. But put the two of these together, spaces it out. Heim joint is right in the middle, right where it needs to be, and this part right here is done. Moving along. Now, the opposite end of the control arm will have a polyurethane bushing on it. The reason why I chose polyurethane, there simply isn't enough room to put in a rod end or a Heim joint, or even getting a uniball with a housing in there and all that. It's not going to happen just by design here. This control arm is a little complicated, so a good solid polyurethane bushing will definitely do the trick. Now, what I'm turning down right now, this is all 6061 aluminum. I'm turning down what we call bushing dummies. It's basically the exact same size of the bushing to take the place of the bushing in the jig while we weld, because you can't weld with polyurethane in there. It would simply melt. So these are being turned down to the size of the bushing with a 12 millimeter hole in the middle of it. Turned down the exact same shoulder on it is 2-inch OD, 1/4 inch thick, and that will take the exact same place of the bushing itself, of the polyurethane. So it's imperative that you have these bushings, or these dummies, turned down and correctly spec'd out. Just really important. Otherwise, it's stuff's not going to work right. So Now, after measuring, we got 1.9 inches on the other end, which is what it needs to be. So if we subtract 2/4 inch shoulders for the bushings, we know that the center section needs to be 1.4 inches long. That's going to be cut out of 2-inch OD with a 1/4 inch wall DOM tubing. As soon as it's all cut to length and cleaned up real quick, slap it all together, this side is done. Now, I really hope you guys dig detail, because we're going to have to go through a lot of it in order to get our layout correct. Now, this can be done easily with design software, CAD, anything like that, but understanding how to lay out a 2D part essentially on your table will basically make even CAD easier when you choose to learn it. Or if you don't have the time to learn it or just want some onesie-twosie stuff, you don't need CAD. I mean, it's just an additional expense and more time. So we're going to focus on doing two-dimensional layout on the actual table itself. Spoiler alert, this is the part we have to make. Now, the control arm itself, in factory form, is not that complicated. It's 3 holes in a pocket, 3 mounting points, and one open spot, basically. So what we're doing with the new control arm is using a tubular construction for one end to be adjustable, and then the open end, or the pocket end, has to be constructed out of sheet metal. I don't really want to just do, weld a tube to an open pocket or a piece of square or something like that. It would kind of look terrible, and of course I question the strength properties of that, simply because it just, well, never mind. It's a lot of math that goes into that. Let's focus on the layout here. All 3 of these, in a simplistic form that we're sitting at right now, all 3 of these holes are on the exact same center line. That will be our reference. If you don't have all 3 holes in the exact same center line based on whatever you're building, you need to find out what the center line is that you're going to reference. So we need to end up making 2 profiles for this. And the first one that I'm going to start off is the side profile, and after this we'll show you the top profile, or the way that we're viewing it. So that way we can get all of our pieces laid out correctly with exact dimensions so we know exactly where to cut. Now, all of these are based off of the same center line, as mentioned earlier. So I'm going to measure from one end to the other. The 2 mounting bolts on each end of it, I'm going to start with that measurement, center to center. Very, very simple. We'll base that on the center line, or we'll mark it out on the center line of the table. Then I'm going to go in and measure from the end to the open pocket, or the bolt hole through the pocket itself. The easiest way I have found over the years to find the centers between bolt holes is to measure the inside to inside of each one of them, then add the diameter of one bolt hole. In this case, we're measuring out at 70 millimeters, and we have a 12 millimeter bolt hole. Therefore, the distance between centers on those bolt holes is 82 millimeters. That's what I'm going to mark out on the table. Next, I want to give myself something to reference at the end of the control arm for this profile. In this case, it's a 2-inch OD bushing housing. So you can use a compass to draw this out or whatever the case is, but in the event that you don't have one, like I don't have one, you can just simply take half the diameter, which is 1 inch in this case, mark it out on 2 spots, take something that is 2-inch OD round, mate it up to those 2 spots or butt it up there, and trace it out. This will give you basically a centered profile, which is exactly what we need. Now we need to start working on that pocket, and the pocket has to be pretty much the exact same size as what's on here, so the dimensions are relatively critical. We need to have the same amount of clearance and everything else that goes in there. So the first thing we need to do is figure out where the top of this is in relation to that bolt hole. That's what I'm going to measure off of. But you notice I can't get the center of it just right, so I'm going to measure from the top of the bolt hole to the top of the pocket. In this case, I have 18 millimeters. Now we're going to add half the diameter of the hole to get the center. So 26 millimeters from the center of our bolt hole, which is marked out on the table, to the top of the pocket. This makes the top of the profile. Now, if you haven't made a dive for the comments yet expressing your complete discontent for the fact that I'm jumping back and forth between metric and imperial measurements, please hold for a minute while I explain. It's just a number. That's all it is, just something that we can reference. I'm very sorry if that confuses you that I'm going back and forth, but in this case, since we have metric bolt holes, we might as well take the metric measurement and just add accordingly from there. The digital caliper that I'm using switches back and forth between the two of them super fast, so forget about conversion and all the rest of this stuff. I'm just measuring it as is. So we're going to continue measuring in both metric and imperial units, but realize it's literally just a number that goes onto the table. That's it. So, moving on. With the top pocket profile sketched out on the table, we now need to get the bottom profile. Now, one could simply measure from the top to the bottom and get pretty close, or with any kind of degree of accuracy, but I'm actually going to measure from the bottom of the bolt hole to the bottom of the pocket. In this case, it measures out to 40 millimeters. Now we add half the diameter of the bolt hole, and we got 46 millimeters from the center of the bolt hole to the bottom of the pocket. Again, you could measure from the top all the way down, but, it's It's up to you. I think this is just a little bit more accurate. And every single measurement is also based off of our center line, so keeping with that, it's a little less confusing. Additionally, I'm going to add what we call a quick drop hole. Now this, in the suspension or car world, a quick drop hole is kind of an old school way of lowering your vehicle in a hurry. Nowadays we crank down coilovers or even put airbags on and stuff like that, but in the event that you don't have time to do that, like going to a show, you don't want to sit there and crank coilovers for a nice static drop. You'd rather just jack up the car, change the location of the bolt hole, and throw it back in there. So in this case, we're dropping it 1 inch. This is totally optional, not needed. I'm literally just doing it for fun and kind of reflecting on once upon a time. So a quick drop bolt hole 1 inch below the factory mounting point will net us a 1 inch suspension drop if we install the strut in that bolt hole location. Pretty simple. So with the top and bottom pockets sketched out on the table, we can move on to getting the sides of the pockets for our clearance. Now this is going to be a relatively rough estimate here because the center of the bolt hole is actually not centered with the pocket itself. It's actually offset, and I don't have any accurate way to actually measure it, so we're going to have to divide that bolt hole visually with the edge of my square here, and then I'm going to measure to that point from the side of the pocket. In this case, it comes out to about 1.5 inches. Then I'm going to do the same thing from the center to the front side of the pocket, which comes out to about 1.25 inches. Both of these are going to be marked out, and this is now the complete boundary of the pocket. Now if you look carefully at the actual pocket itself, you'll notice that it has radiused corners. If we take a measurement, they actually come out to a 1 inch radius, or a 1/2 inch distance between the end of the radius and the actual edge of the pocket. This area right here, I'm not going to add a radius, but I'm actually going to add a couple of break points. This is where I'm going to break that profile or bend it in order to mate the profiles correctly to either the bushing housing or the other end where the tube is. It's also going to make it look a little bit less boxy on here. It's going to give it some more of a really nice kind of streamlined, kind of look, if you will. Just kind of clean it up a little bit. Not necessary, but a unique trick. Now, this may look a little bit confusing right now, but you'll see exactly how all that works here in just a few minutes. Now, up till this point, what we laid down is exactly what we have to have. The rest of this is what I choose to have. So I'm going to take a quick minute here and I'm going to stare at this and I'm going to kind of look at the profile and kind of envision it a little bit. And I'm going to put down a theoretical termination point, and I'm just going to basically just draw a line, in this case about 4 inches away from that pocket. And I'm going to write a T for theoretical or termination point. This is just literally a guess. I'm just going to go with what I feel, if I like it. If it turns out, looking pretty good. Now, one of those things that kind of helps me out just a little bit in determining if I like it, if it flows really well or anything like that, is to start drawing all of my lines for this profile itself, or start connecting everything. That way I've got a good vision of the flow here, if you will. So I'm going to draw a line tangent to our bushing housing that leads up to the break point on the pocket. Not the actual end of the pocket, but the break point itself. This is going to give me a general idea of what the profile looks like at the moment, or what it sits at right now. So I can kind of try to match this up, extend it out a little bit, play with it somehow. I don't know. I'm just shooting from the hip and seeing what I think it, looks pretty good. Now we are running from square to round essentially, and we have to taper each one of these down to basically meet up where the actual tube goes through this point, or where it transitions over. That's why I want it to be kind of extended or kind of streamlined a little bit, if you will, make it look kind of sexy and not quite so boxy, just kind of junky looking. I want it to look pretty clean. I want, smooth. So one of the first things I have to do on this one is to add the dimensions of my tube. Just kind of put that in place so we can draw some lines through it. The tube is 1.25 inches OD, therefore half of it is 5/8 of an inch. I'm going to mark that out on the table and then draw my lines to represent that. And finally, I'm going to draw a line from the break point on the back section of the pocket. I'm going to draw a line from there through the theoretical termination point where it intersects with the actual tube itself, or what represents the tube. So straight through that point, I'm going to do the same thing on the bottom as well. You got to make sure that these line up. Now when I take a second to step back and look at it, I can see, well, maybe I like it, maybe I don't, maybe my termination point needs to be moved a little further down or something. And we got to kind of get a general idea of if this is going to work or if it's not going to work or anything else like that. Now after looking at this, I'm pretty content with it. I like it. Now the only thing I have to do is actually extend the basically extend the termination point, or the theoretical termination point, back just a little bit. The reason I have to do that that is because the thickness of the sheet metal itself. Since we're going from square to round, there's going to be excess material due to wall thicknesses of the actual sheet metal itself. So the actual termination point where I have to mark it out on the sheet metal and where we're going to start cutting is actually about an inch or so back or rearward of the actual termination point, or that theoretical termination point. Probably doesn't make a lot of sense, but you'll see it as soon as we actually get to cutting all of this out and marking it all out and everything else like that. And of course the process to cut the hole out in the tail section, you'll see a really neat trick on that one too. So with our layout complete, let's take a look and see exactly the part that we're doing. All these lines and all this stuff that we just drew out, this is the part that we need to cut. Pretty simple, yet kind of complicated. Of course, we could have whipped this out in about, I don't know, maybe 5-10 minutes on CAD, but again, knowing 2D layout, it's a good thing to have. It's a good thing to know. So let's move on to the top profile, but this time we're going to kind of speed through it just a little bit quicker, since it's basically the same thing. So the top profile pretty much has to have the exact same meat and potatoes, or the standards, or the the must-haves on there. Okay, so we've got to have our bushing housing, we have to have our pocket, we have to have our center line, our tubes, our everything. So the first thing that we're going to measure out is the bushing housing itself. It comes in at 1.4 inches width, not the diameter, the width. Okay, that's what we need to have on there. So 0.7 on each side gets us a reference to where it is. And remember, we're doing everything from the top now. So everything that was on our boundary, we were able to actually extend up from the side profile drawing. So things like the break points, the length of the pocket, that can be extended upward. The width of the pocket, that's what we need to measure out. So that one comes out to 1.9 inches. So you can see it's actually relatively easy to make your top profile. In all honesty, most of it's just tracing it all up. You only have to take one measurement, and that's the width of the pocket. So after that, I'm going to make my tube references. So we have an 1.25 inch tube. I'm going to make sure that we get these lines drawn. The tube has to be on there, of course, because we need that basically that reference for the profile. I'm going to extend up my theoretical termination point and the termination point that I'm actually going to use, because remember, we have to compensate for our wall thicknesses and everything else like that when we cut the profile for the tube to slide through it. Now I'm going to run back up to the front section here, and I'm going to mark out the entire profile for the bushing housing. Now that housing that is there, we need this on here, and I almost forgot to sketch it completely, so we need to make sure that it's all on here so we know where the metal is going to terminate, and I want to make sure that it terminates with at least 1/4 inch of wall still remaining on there so I can weld to it. Then I'm going to extend my lines. My lines are going to go from the break reference up to that 1/4 inch portion that I marked out for the bushing housing itself. Then I'm going to go to the back side here and run the same line through my theoretical termination point where it intersects with the tube up to the break reference. Now this section is done. Now just like before, we'll pull up a graphic overlay here and show you the part that we just basically sketched out. This is pretty much what it looks like, or at least there's 2 of them there. Now I realized I just absolutely flew through the layout of the top plane, but understanding we use the exact same methods, the same thing, the same ways to get the measurements, maybe a couple cheater tricks and all that, and all I really did on this one was just kind of show you which pieces I need to measure and from which angle. So, I mean, you just have to really understand which plane you're looking at and which plane you're sketching out. So virtually everything else is exactly the same. Same methods to get it, all the rest of that good stuff. I really hope you guys have learned something on this one, and hope you actually made it through that one. If you did, good on you, man. That's dedication right there. Layout is not a very fun or exciting topic. In fact, it's difficult to get through even on the editing side of things. So maybe there's something good for you, maybe a reward that's going to pay out here. Here's a challenge. Many people were mad that I used the word jig instead of the word fixture when I say it's potato potato. So guess what? We're going to go back, count how many times I use the word jig in part 1. Combine that with the amount of times I say jig in part 2. If you're one of the first 5 people in the comments in part 2 to get the answer right of how many times I use the word jig, I'll send you a really awesome, cool pack of goodness from TFS. Just my way of saying thanks for sticking around this long and learning something. Now, if you got any questions or comments, throw them down there in the comments box below. We'll see if I can get back to you, maybe explain something better. You know the socials. FabricationSeries.com website, Instagram at the.fabricator, and Facebook.com/thefabricatorseries. Now, thank you very much for watching. I'll see you guys over on part 2.